Let's take a look at just some of the tools that are available inside of SolidWorks for working in the oil and gas industry. You see this skid mount system shows many of those capabilities. Many pipe spools inside of this design. Also tube routing can be very important. Weldments is another key area of the design process, and even things like P&IDs can be easily done inside of SolidWorks. Let's switch to the assembly and get started. Let's take a closer look at our assembly. You'll see that there are several pipe spools in this design already. We're actually going to be adding one of those and show you how we create those inside of SolidWorks. Also, you'll notice that there are some tubing components as well, and you may also notice that we have some large weldments. What I'm going to do is I'm going to switch to a different display state. Display states really allow me to remove unwanted clutter from the screen, allow me to focus on my design. Let's get started creating our first pipe spool. To do this, we access the design library. Here we have many components that are stored. You notice that you have a couple flanges that we want to be able to use. To access those, we simply drag them and drop them into SolidWorks. SolidWorks Smart Mates that into position. All we need to do is choose which size. You'll notice that information that gets stored with this pipe flange is information about the pipe, also information about the elbows that are to be used in this pipe spool. This takes me immediately into the 3D sketch environment. Here I'm able to draw in any direction. And one of the things you'll notice that as I draw, SolidWorks is automatically adding fillets in the corners. These fillets represent the elbows that are to be used, and SolidWorks places the appropriate fillet dimension on there. It's connected up to our tank simply by adding another flange to our design. SolidWorks starts that pipe, and then we'll connect the two pipes together. You can see SolidWorks adds yet another fillet in that corner. Now we may want to tidy up our design, so here we're just going to remove the pipe and weld directly to the flange. Now at this point, all we've done is dropped in a couple of flanges and drawn some lines. SolidWorks has taken care of mapping all the pipe information onto that. You can actually see we've created a subassembly. This subassembly contains 8 components, the 2 flanges, 3 pipes, and 3 elbows. So all this gets done automatically by SolidWorks. Let's continue our design. Go back into our pipe route, and we're going to start to add some additional items. We're going to connect up to this port on the tank. Notice that this one is actually a 3-inch diameter pipe, so we're going to need to choose a different size when we place our flange in. Here we'll choose the 3-inch pipe. Again, SolidWorks knows that this is now a 3-inch pipe, and it knows to associate the appropriate elbows for that. We want to connect this into our pipe route, so we'll simply add a point to do that. Here we're going to use the auto route capability. The auto route allows me to automatically do my pipe route. SolidWorks also gives me an indication that we have conflicting properties for our pipe. It knows that we have a 3-inch and a 4-inch, and we'll deal with that in a little bit here. You can see that we can change the various paths that we have. In this case, we've chosen a different path than the one that was originally presented, and then we can actually move that around in our design. We can even add dimensions. Here I'm just going to add a dimension to keep it, say, 5 inches away from the outside of our enclosure there. So once we have that done, you can see that we can still move our pipe route around. At this point, we can continue to add more dimensions to locate this. But we're going to need to connect that 3-inch pipe into our 4-inch pipe, and to do that, we'll use a reducing T. Notice that SolidWorks here chooses the appropriate 4x4x3 configuration. All we need to do is choose which schedule we want to use. If we want to add in a valve, it's again simple as adding in yet another point to attach it to, and drag and drop. SolidWorks will place that valve in there. Now one of the great things that SolidWorks is doing behind the scenes is it's actually splitting the pipes. SolidWorks knows where to split each of the individual pipes, say where it intersects with the T or with the flanges for the ball valve. Let's take a closer look at our pipe spool. We're going to open it up in its own window. You can see that this is a subassembly that has many components. There's actually 20 components that we've added to this assembly simply by dragging and dropping flanges and placing various components around. You can see here that we have individual parts that represent each of the individual pipes, whether they be 3-inch or 4-inch pipes. We may want to add in something else like a pressure gauge. In order to do that, we're going to need to have something to mount that to. Here we're just going to access a threadlet. Here you can see the different sizes that we have. We'll place that into our design, and SolidWorks automatically smart mates that into position for me. One of the things you'll notice with this threadlet is we're going to need to have a hole in our pipe to do that. And SolidWorks provides a great capability, in this case, smart features. Smart features allow me to store features inside of components so that those features can quickly be added to other parts. Here we've added the smart feature for the threadlet. Simply by hiding that, you can quickly see that it's now added the hole that needs to be cut at the appropriate size into the pipe. We want to add in our pressure gauge, so we'll simply smart mate that into position as well. You can see how quick and easy it is for us to be able to do that. Next, we're going to want to document our design. So we'll simply create a drawing of our pipe spool. Here all we need to do is drag out any of the views that we want on our drawing, front view, a top view. Let's also place an isometric view onto our drawing sheet as well. Now no assembly drawing is complete without a bill of material. So we'll place a bill of material onto our drawing. And one of the great things that SolidWorks has done here is not only has it quantified each of the parts, extracted all the part number information out of those parts, including descriptions, but it's also given me the length of each of the pipe segments. All that information gets captured and stored with each of the individual pipes as they are created and as they are edited. Let's add some balloons to our design. You can see SolidWorks automatic ballooning capability automatically adds all the balloons for all those components as well. Here we just move some around onto the sheet. Another thing that might be important is you might want to have dimensional information on your drawing. So here we'll just turn on the center lines for our pipes, and then we can add any dimensions that we might want to have on our drawing for reference. So you can see that SolidWorks provides some really great tools for creating, editing, and documenting any of your pipe spools for your designs. Let's go back to our main assembly. Now notice the change that we made when we were inside the pipe spool subassembly by adding the gauge is automatically updated here at the top level assembly. What we want to do is we want to turn all of our components back on, see how our assembly is starting to take shape. Now you may notice inside of this enclosure there are several tubing components. Let's open that up in its own window. You can see the various tube routes that exist inside of this assembly. Again, we'll leverage the display states to turn off unwanted items from the screen. Just hide the enclosure. Now what we want to do is we want to create a route similar to this one here. We're going to go from the manifold over to the fitting on the far left. To do this, we're going to access our library again. Here we're going to use our tubing fittings. Simply drag out a fitting, choose the appropriate size, 3/8 tube, 1/4 inch MPT, place that into our design. Again, the information about which tube to use for this fitting is stored. Here we can change the bend radius if we want. We'll make it 1/2 inch. We want to connect up to our fitting on the left, so we simply add this to our route. Then we're going to use the auto route capability to route between this point and this point. And you can see then SolidWorks gives me the ability to actually make edits, change that around, move that around on the screen, and get it into an appropriate position for what we're going to do. Now this tube is a little different than the one we did previously. Previously we actually added elbows in all the corners. This time here we actually have bends in each of those corners because it's bent copper. All that information is stored with this pipe route. Here we're going to choose to export that information. This can be very important if you need to export this for your pipe bending equipment. Here we've created an HTML document that stores all the information, X, Y, Z bend radius information that is needed to manufacture this particular pipe route. The next thing we want to do is we want to add some more components to this route. What we want to do is we want to connect in the control valve. Here you'll notice that this hole for this fitting is going to be 3/8 NPT. So we'll go back to our library, place a straight fitting in, this time choosing just a different size, the 3/8 NPT, but same size tube. We'll add the appropriate pipe to that fitting, and then give it a place to connect to. Now we'll go ahead and use the auto route feature to route between those 2 points. And once again, SolidWorks does a great job of automatically routing between the points and adding all the appropriate bend information to my design. Let's connect those 2 pipe segments together using a T-fitting. Notice as I drag and drop that into my design, SolidWorks orients it properly and chooses the proper size. Now just to change things up, you'll notice that there are some sweat fittings in the corners. SolidWorks is very flexible, allowing me to use bent pipes, or in this case, we'll just delete the bend information off and use a sweat fitting by dragging and dropping. Place 2 of those into our design. One of the benefits of SolidWorks routing tools is that behind the scenes, SolidWorks is always trimming up the pipes to be the appropriate length for manufacture. So again, you can see as we did before, it's simply a matter of dragging and placing various fittings into our design and drawing some lines to connect those, and SolidWorks takes care of the rest of the routing the pipe. Turning on all of our components, we can see how our new tube route fits into our assembly. Let's open our tube route up in its own window, and just as before, SolidWorks has created a subassembly, in this case with about 10 components. Let's document our tube route design by creating a drawing. Just as we did before, simply place the views that we want to have on our sheet, front view, a top view. We'll also place an isometric view on there as well. Things like changing the scale of a drawing is very easy in SolidWorks. Here we'll just change the scale to 1:2, and then we can reposition any of those views around onto our drawing sheet. Need to have a bill of material for our tube route. Place that into our design, and again SolidWorks is going to extract all the part numbers, descriptions, quantify each of those for us, and most importantly give us the length information for each of those tubes for manufacturing purposes. It's very easy to add the balloons with the automatic balloon capability, and there you can see we've now documented our tube route assembly. So those are just two examples of the power of SolidWorks routing tools. Let's go back to our main assembly, and once again you'll see that everything is always up to date through the power of associativity. Back at the main assembly you can see that our enclosure is now up to date with the new tube route that we just added. The next piece of functionality we want to take a look at is weldments. You may notice that the pump is just floating in space. What we're going to do is build a weldment structure to support it. We're going to use the isolate command to really focus in on just those two components where we're going to be building our new weldment structure. Let's add a new part to our assembly. We're just going to place it on the center plane of the pump. Now we want to leverage the location of the pump in our assembly. All we need to do is borrow an edge, and we'll convert that into sketch geometry. We'll then use that as a path to sweep a rectangular cross-section to create our plate. To do this, we'll use the weldment tools. Notice the various libraries that we have. In this case, we're going to choose plates. We'll also choose a thickness. We'll choose 3/4 inch thick, and then we'll choose a width. For this case, we don't really know the width yet. We'll just choose 12. We can always change it down the road. SolidWorks gives us a nice preview of what our plate's going to look like. We'll go ahead and accept that. As I mentioned before, if I wanted to make this wider, simply click on a dimension and make that change. Now we're going to define the rest of our weldment structure. We're going to do that by sketching on the side face of the plate we just created. For this sketch, we just want to draw half of it. So we'll put a center line down, and we'll use that later to mirror our geometry to the other side. Here we'll just go in and sketch out the shape that we want to achieve. Here I'm just going to jump to a front view, and this will help me to infer or snap to that top edge of our floor plate. Draw one more line at the bottom, and here I'm going to add a midpoint relationship. Notice as I drag it, both sides move equally. We'll add some dimensions to our sketch to further control the size. The bottom plate is just going to be 6 inches long, and then we're going to need to mirror that geometry to the other side. Let's go back to our weldment tools, and again we're going to create another plate. This one's going to be a 1/2 inch thick plate by 3 inches wide, and again we're going to choose 2 path segments this time, and you can see that SolidWorks has then oriented my cross section along that, and it's going to create both of those at the same time. Next we're going to add a structural steel tube to this particular member. Again, back into my libraries. Here I'm going to choose some of the various sizes that we have. A square tube. We want 2.5 by 2.5 by 1/4 inch, and then SolidWorks will go ahead and map that cross section onto my design. Now you may notice that that tube runs right through my plate. SolidWorks gives me a great tool to locate that profile. Here we'll just choose a different point for it to run along that path. Then we'll add some additional lines to get some additional tubing members. Now you may notice that the corner treatments are already taken care of. SolidWorks gives me great tools to control the corner treatments. We also have individual controls, so I can change those individually. For this design, we're going to use the mitered corner treatment. Now you may notice that the tubes run all the way down to the floor plate and actually interfere or run through the foot pads. What we're going to need to do is trim those back. To do that, we'll use SolidWorks Trim Extend tool. Here we just choose the items that we want to trim, and then choose a face that we want to trim them up to, and we'll let SolidWorks take care of the rest. We're going to need to have symmetry in our design, so we'll take these members and mirror them to the other side, using the front plane as our mirror plane. We'll just choose the items that we want to mirror. We'll let SolidWorks handle it. Let's turn off some of these sketch lines that we don't need to see anymore. One of the things you may notice is that the pump has some mounting holes. Now we don't need to get the catalog out and look up what size holes those need to be and what are the bolts that need to go in there, because this is a smart component. You can see as I choose the smart component, I get the star that tells me it's a smart component. Here I'm presented with a dialog telling me what it's going to add. In this case, it's going to add some tapped holes to my mounting plate and then add all the bolts and lock washers. All I need to do is choose the face that I want to mount it on. Notice that SolidWorks has added the bolts and washers to my design, and it's also added the holes as well. Let's open our Weldment up in its own window. Here you'll notice those are the tapped holes that were added from my pump smart part. Those are the smart features. The next thing we want to do is we want to add some cross stiffeners to our design. Again, go back into the sketch environment. All we need to do is to draw in those paths. Here I'm just going to draw a line from one side to another. We can add some dimensions to control the size. And we'll do the same thing on the other side. We'll go back to our structural members. And in this case, what we're going to do is we're going to add in an L angle. This L angle is going to be 1 by 1 by 1/8 inch. And then we'll choose our path segments. Notice we're going to need to rotate this one. SolidWorks gives us that capability. We'll just rotate that 90. We'll do the same thing on the other side. This one needs to be rotated 90 as well. Now you notice with these L angles, they're going to need to be trimmed and extended. The trim and extend tool inside of SolidWorks does this all in one shot. Simply choose the items that we want to trim and the face that we want to trim and extend up to. SolidWorks does a fantastic job. Next we'll apply a material. Now not only does this change the color, but also establishes all the mechanical properties such as density and all the structural properties for analysis. Let's take a look at the cut list. You can see that all these items exist individually. SolidWorks can automatically generate our cut list. Now you can see that it's grouped them into identical members. And this is really great for creating the cut list on our drawing. Let's save our Weldment and then create a drawing of it. Just as we did before, simply place our views onto our drawing sheet by dragging and dropping. Here we'll drop on a front view, right view, top view. We'll also throw in an isometric view as well. Before we created bills of materials to identify each of the individual components. In this case here we're going to create a cut list. All the information that we identified earlier with our cut list inside of the part is now identified here. But we're also extracting information about the size of each of those components. Also the lengths. This is very good information for manufacturing this item. We can add our balloons. We might also want to finish the detailing of this part by adding some dimensions. Here we're going to use SolidWorks Dim Expert capability. All we need to do is identify the origin point that we want to dimension from, and then simply by selecting various edges, SolidWorks goes and extracts all the locating information for each of those items. Here we'll choose the main central mounting plate, and then we'll also choose some of the holes as well. And here you can see SolidWorks extracts all the dimensional information, including the hole callouts for those holes. And then we can continue to do this to the rest of the views if we wanted. So I hope you can see the power of SolidWorks Weldment design capabilities. Let's go back to our main assembly. Notice that those cross members that we added when we were in the part mode automatically updated here at the main assembly level. Let's get all of our components back on and then take a look at automating some change. Maybe we want to move this pump up. Simply by selecting on the pump, we have access to all the mates, all the locating information for that pump. We can change the pump height here, change it from 12 to 16. Notice as I rebuild my assembly, not only will the pump move up, but our new weldment will update as well. Also notice all the pipe spools that we had attached to that pump have also been adjusted as well, including the pipe supports. So some really powerful capabilities of being able to build these models and build this information in the context of your assembly. Now we've talked a lot about automation and how we can reuse existing components. Let's open this ladder up in its own window. Now this may be something that's used quite often in your designs. In this case here we've actually done some automation. Let's take a look at the equations that we have. We have some equations that control the number of cage hoops based on the height. We also control the number of rungs that we have in our design based on that height as well. The height is controlled from a 2D layout that we've started with, and then we built all the rest of our geometry from that. Notice as I drag the platform height, you'll see that not only does it change the height of my ladder, but it's also changing the number of rungs that I have and spacing them evenly throughout. As I get higher, you'll also notice that the number of cage hoops changes as well. So this really helps me to automate some simple tasks when I reuse this over and over again. Let's take a look at the drawing. The drawing updates to those changes that I've just made, and you'll notice the bill of material always up to date. Here it's listing we have 19 of those 3/4 inch round bars, and those are our rungs. We can also make changes from the drawing environment. Here we'll change this to 13 feet. We'll rebuild and get our ladder back to the proper height for this design. And then you'll notice the bill of material is up to date with 13 of those rungs. So hopefully you're able to see that SolidWorks has some fantastic tools for automating simple tasks. Let's take the concept of design reuse and automation a little bit further. Let's take a look at this horizontal tank. This is a simple horizontal tank again that we use over and over again. And as we did before, we created a 2D layout that identifies key information about this tank. Let's edit that sketch. You can see all the dimensional information. One of the things you'll notice is that this has an elliptical head, and there are certain equations that control that elliptical head. Now if we just want to change the length of our tank, we can do that simply by clicking on a dimension and changing its value. But what happens if we want to change the diameter of the tank? That's going to involve some calculations that are based off of standard equations for the elliptical head. For this example, we've captured those equations in an Excel spreadsheet, and we've included that Excel spreadsheet inside the design binder for this part. So now you notice this Excel spreadsheet has quite a few calculations inside of it. I won't get into the actual calculations, but you can see that there are many of them that are in this particular spreadsheet. There are even checks that says whether or not this design is okay. What we want to do is we want to change the outside diameter of our tank from 42 to 36. You can see all the dimensional values that update. Even the check says whether or not it's okay. Now that we have some new dimensions, how do we get all these dimensions back into SolidWorks to control our design? Well, we're going to do that by using a macro. This macro is actually embedded inside of SolidWorks. So as I click that button, watch the geometry on the screen, it actually updates. So we have some macro information inside of an Excel spreadsheet that's controlling our SolidWorks geometry. This is really very simple. With some simple visual basic skills, what you can do is record a macro in SolidWorks, paste this information inside of Excel, and then have those dimensional changes reference cells that are in the Excel spreadsheet. Here we're referencing cell B8, cell B10, B12, so on and so forth. So it's very easy. Let's take a quick look at how we would build a macro inside of SolidWorks. To do that, we simply engage the macro editor. This is built inside of SolidWorks. What we want to do is maybe change the location for the supports. We're going to choose to record a macro, click on a dimension, make a change, and then we'll hit rebuild. And just that information gets stored into that macro. And then stop recording, take a look at the macro that we've created. Here's the macro. It's very similar syntax to what we have inside of Excel. All we need to do is take this information, paste it into Excel, and you can see where it's actually changing the dimension right here. All we need to do is say, go use the value from an Excel cell. And that's all we need to do that. So some really great tools to take your automation to the next level. And finally, let's take a look at one more capability that SolidWorks has for customers in the oil and gas industry. In this case, we have a simple P&ID that might identify some of the items that we've been working on so far. Here we're just leveraging 2D information. And back to our library, we're just going to leverage some existing blocks that we have. Maybe we want to drop in a flange, simply drag and drop and snap that into position. Maybe we want to have a valve, again, dragging and dropping, placing those into our design. another flange, and then we'll finally finish it out by just sketching in some additional line work to finish out our route. And then we can just use standard 2D techniques, move things around, position them onto our drawing sheet. So hopefully this demonstration has shown you just some of the capabilities that SolidWorks has for customers in the oil and gas business. We were able to show you the pipe spools and the drawing creation of each of those, tube routing, weldment design, automation of simple tasks such as the ladder or the tank. You might notice that as we made that change to the tank and shortened it, that pipe route is up to date.